let's solve questions now. Now the first question I have with me here says, a boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton. Were you not shocked as well? A boy drags a bag of rice. Can a boy drag a bag of rice? But it's a smooth horizontal floor. If it wasn't a smooth horizontal floor, a boy cannot drag a bag of rice. Well, I don't know. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton. Is that not too small? So the force is 2 Newton applied at an angle of 60 degrees. So angle of inclination 60 degrees to the floor. That is, the angle is made with the floor, 60 degrees with the floor. The work done after a distance of 3 meters. So the distance covered is 3 meters. So we are looking for the work done. Of course, everybody knows that the formula for work done is what? Force times distance. But in this case, if you use force times distance here, that's 0. Now, if you notice something about this question, wow, this is kind of corroborating what I said earlier. Did it talk about the weight of the rice? No. The question says a boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle of 60 degrees to the floor. The work done after a distance of 3 meters is. So the weight is irrelevant here. The only case whereby this weight can be relevant is if we have what? If there is friction, if the surface is not a what? It's not a smooth surface. So wow, this is very, very good. So I like this question. So what we have here is that let me get a diagram. This is our bag of rice. Don't mind me. This bag of rice on the floor. Now let's say this is the boy. Now the boy wants to apply force on this. The bag of rice shouldn't be that far away from the boy because the boy is not a magician. So if this is the bag of rice that the boy wants to do, so the boy stretches his hand to this bag of rice, and the angle of inclination there is angle 60 degrees. So which means that this boy could have actually lied down and apply the force of 2 Newton directly, so that nothing will happen, because if you apply the force directly, maybe the bag of rice is on a table, so you are able to apply the force directly without having to incline it at all. It will be the pushing of the object will be much more effective. But because you are inclining it here, then you have the effect of this force is being reduced. Let me tell you what is happening here. So if I want to assume that, okay, I'm looking for an horizontal force, an horizontal equivalence of this force 2 Newton that is using. So this is 2 Newton. So let me draw this out now. This is a triangle. So we have 2 Newton here, and we have what? 60 degrees here. Now this force 2 Newton, we have its maximum effect if this object is actually being pushed or pulled towards himself in this direction. So this 2 Newton will have its maximum effect if that bag of rice can actually move in this direction. That means that the bag of rice will be lifted from the floor and it's now move diagonally through the air. Then the 2 Newton will have its maximum effect. Now, but in this case, the force is acting in this way, but the thing that the force is acting upon is moving in this way, which implies that something is happening. The force is not having its what? Its maximum effect on it. So if I want to look for the equivalence of this force on this horizontal line, I've already stated that all you just have to do is what? Just resolve. And since the angle is between the line of action of the force and the surface that we are talking about, the angle is between them, so we make use of what? Cos theta. So the equivalence of this force, which is our resultant force, is what? Is 2 cos 60 degrees. And if we press our calculator very well, we will realize that cos 60 is 0.5. So this will be what? This will be 1 Newton. So instead of a force of 2 Newton that is actually supposed to push or pull this bag of rice area, that implies that the force responsible for the pulling of this bag of rice is 1 Newton. Even though the boy is applying what? Is applying a 2 Newton force, but the effective force on that rice is what? Is 1 Newton. And so now, work done, which is force times distance. So the work done has to be the effective force times the distance moved, not just the any force anyhow. So we have our work done now will now be equal to, that's 1 times 3 meters. So the work done there is what? Is 3 joules, which is the correct answer there. Now that's the end of that question. Let's take another question. This question says, calculate the magnitude of the force required to just move a 20 kg object. Now something is going to happen here. Notice, so calculate the magnitude of force required to just move a 20 kg object. Now mentioning the mass is telling me that there's possibility that there's friction there. Let's see. Along a horizontal surface, if the coefficient of the friction is 0.2, is that not amazing? So the force does not actually have to overcome the mass. That's the fact that you need to know. The force does not actually have to overcome the mass. The only thing the force has to do is force to be applied, then the mass moves. But it's friction that is always reinforcing. Please take note that it's frictional force that is always reinforcing the effect of the mass, that is the weight of that object, that makes it difficult to actually push or pull objects or drag them along any surface. So this guy, the surface we are pushing this guy along has coefficient of friction to be 0.2. Then we are looking for the force required to just move it. That means that whenever you say a question, you say to just move it. Then we are looking for that force that we only that we just overcome the state of rest of that object. We are not interested in the force that we first move it and makes it accelerate. No, that's not what we are interested in. We're just interested in a force that will make it start moving, that will make it get ready for movement. Because if you actually want to make a body start moving, number one thing you need to do is what? You need to overcome its state of rest. So we need a force that will overcome the state of rest of this object. So when we find the force that will overcome the state of this object, if we are not interested in making it move faster or anyhow, then we can apply more force so that it will what? So that it will accelerate. But in this case, we are not interested in that. So which means that, and what will be that force? That force will just be the force that will overcome the frictional force. And the force that will overcome the frictional force, it will be the same in magnitude with the frictional force as well. So all we just have to do is here is what? Find the frictional force. When we get the frictional force, then we have solved this problem. So the frictional force, don't forget, is what? Frictional force equals mu r, which is mu mg. This question is quite easy. So that will be 0.2. The mass of the object is 20 kg, and our g, the normal approximate value of g is 9.8 meter per second squared. But as we use it here, we use 10 meter per second squared. So permit me to just use 10 meter per second squared. But it is, the approximate value is 9.8 meter per second squared. So if we multiply everything that we have here, we see that we have what? A force of 40 Newton. The frictional force is 40 Newton, but that's also the same force that is required to what? To just move the body from the horizontal surface. So we get that. Now let's solve another question. Now this question says, a wooden block of weight 16 Newton is placed on a rough surface. You notice something here. Whenever they mention mass or weight, it is always accompanied by what? By friction. If not, whenever you are talking about force does not have to deal with mass at all. The only force that deals with mass is what? Is the frictional force and the what? And the tension and the weight. Wow, that's enough already, because we have 4 different types of force that we discussed so far, and 3 of them involves weight. But generally, the force that causes an action to happen does not depend on the mass or weight of the body. So it only depends on the frictional force or whatever is opposing it. So let's move forward. So the block of weight 16 Newton. So weight of the block is 16 Newton. It's placed on a rough surface. If the coefficient of friction between both surfaces is 0.25, coefficient of friction is 0.25, the least horizontal force required to move the block is, that's another way again, the least horizontal force, that is the minimum force that it will require to start moving at all, that's still the frictional force. And this is very simple. So you know, we have that the frictional force is mu r. Of course, our r is still the same thing as the weight of that object, so that will just be what? That will be 0.25 times 16, and if I'm not mistaken, that should be 4 Newton. So that's 4 Newton. So, and that's that about that question. So let's quickly take a break. When I come back, we'll solve more questions on force friction.